Let's talk about functions and their input versus their output. Input is typically what goes inside the function, which you can think of as being part of the domain of the function. If I'm working with, let's say, f of x is equal to x squared plus x, then I'm talking about inputs are the x values. If I'm talking about outputs, that's usually involved with the range, and we typically think the output would be either my f of x, that's an output, which sometimes we also call the variable y. So let's say I'm working with f of x is equal to x squared plus x. The first thing that I want to find is, let's say, f of 3. 3 is an input, and this function says whatever you have right here on the inside, you should replace anywhere you see an x with that value. Well, I have a 3, so I'm going to have 3 squared plus 3. 3 squared is 9, plus 3, that gives me 12. So in other words, f of 3 is equal to 12, which also means that the point 3 comma 12 lives on the graph of that function. Versus, let's say I wanted instead to have, well, what's the x value such that f of x is equal to 6? So since f of x is equal to 6, that tells me 6 is an output. My function f of x is x squared plus x, so I'm replacing f of x with x squared plus x, and I want to know, well, when is that equal to 6? Well, I can probably solve this if I shuffle everything to one side, so x squared plus x minus 6 is equal to 0. This side factors, I think it's x plus 3, x minus 2. Which means either x plus 3 is equal to 0 or x minus 2 is equal to 0. Solving these, subtract 3 from both sides means x is equal to negative 3 or x is equal to 2. So there are two locations or two x values such that f of x is equal to 6, which means I know now that f of negative 3 is 6 as well as f of 2 is equal to 6. What that means is 2 points on that graph are negative 3 comma 6 as well as 2 comma 6. If you want to check it, you can. Plugging 2 into my f function, that would give me 2 squared is 4 plus 2. Yep, that gives me 6. And then as well, negative 3 squared is a positive 9, plus a negative 3 also gets me back at 6. So that's an example of how function notation works, input versus output, and depending on which one you're given, how to find the other.